what I'd like to do is bring up David and Uwe for kind of an impromptu question and answer. Since they're the leaders of the two work groups, you can ask the three of us any questions that you would like, and we will do our best to answer them. Or even, we don't have answers. Okay, so David will do his best to answer them. Uwe will just look pretty.
The answer is 42. The answer is 42.
The answer is always 42.
Correct.
So, that one's for the audience? Okay.
There are no questions.
All right. Tom, I'll let you run the audience mic around for questions if you would. Thanks. So any questions for us at all? John.
Brian, first, thanks for the plug for Mettler Toledo. And anytime you can locate the OMAC booth within 100 feet of our booth at PAC Expo, we'll provide the same service every year. Next door would be better. Okay,
we'll see what we can
Milwaukee.
do. Talk to Tom.
Okay. The question is on meetings that are coming up. Is there a schedule for different meetings for the different events or different groups such as PAC Safety and PAC Spec? And you have those there, and you're going to list those? Excellent.
Yeah, I get the information. There was a meeting from the PAC Spec and PAC Safety and PAC Connect group scheduled for March this year. We had to cancel this meeting due to a lot of things going on in Europe. There's vacation time, so Eastern vacation, and there are a lot of exhibitions coming up with Hannover Fair and the big packaging show in Düsseldorf, the Interpack. So we had to cancel that, but the next meeting will take place June 11 and 12 at the Schneider facilities close to Frankfurt. And another meeting from that joint group is scheduled for December 17th and 18th. With a question mark, it will be held at the Optima facilities, which is a German OEM, but that's a question mark. We don't know that yet. And as we have canceled the one in March now, between June and December, that's a long time frame, and we will probably talk about an additional meeting in between that time while we are sitting together in June. So we make a decision in June then. Other than that, there are no meetings there. Tom, you have a meeting planned for PAC Spec.
Yeah, absolutely.
But
I have a
any than
PAC Spec
that.
meeting. It's just in 2 weeks, February 25th in Chicago. There's an agenda, 4 or 5 bullet points. They're all really important bullet points. Sorry. So if anyone's interested, I would love to be able to send you the agenda and get more and more input. Just one important thing that we want to do during this meeting. Sorry, you gave me the.
I should have known better.
One important thing we really want to do with this is the template is awesome. The feedback we got from end users, from OEMs, from anyone that looks at it says, boy, this is what we need, right? It's one thing to have standards, but now a template to be able to apply the standards becomes very, very useful. The one thing that I think we need is some kind of a sample. So we have a template, and we tell you how to do this, but we don't really give anyone something to look at and say, oh, okay, this is how you do it. So that's one of the things, one of the takeaways I think we really need to get out of this meeting that's going to happen in 2 weeks. Come up with a model for how this is supposed to work. So end users, please, I sent you an email. Whoever wants to help with this, I guarantee it'll be fun, because we have the fun committee. So.
Thank you.
Yeah.
Other questions?
David Aarons from Lenza. I haven't been with this group for a little while, so maybe for some of the new people, with the machine tool group using like MT Connect, which is kind of slightly different than PAC tags, is there an adoption of the PAC-ML state model in the machine tool group, or is there a separate model being developed in regards to that?
So I'm not an MT Connect expert. We do have an MT Connect expert here. Basically the MT Connect is addressing a lower level of the actual data it doesn't really adjust the data definition as much as it's defining a transport mechanism. How to do, Paul? I'm not doing well. Okay. Paul's billing.
I think it was last year. Was it last year that we had a meeting to talk about MT Connect and PACML? As far as MT Connect is concerned, in that standard there are events that can occur. So if PACML so wishes to have some of those tag items placed in there, that'd be fine. We don't have any problem with that at all. I think that if that is the case, then we just have to really strike up a conversation again on what PACML would like and what MT Connect can fit into that. What MT Connect is it's standard for getting data at the lowest level, which is at the device level, whether that be sensors, whether it be a control, a PLC, anything like that, which is similar to, I think, PACML. So it's just a matter if yourselves and MT Connect Institute wish to merge these things, I'm really open to it. I'm Paul Warndorf from AMT. AMT is the trade association for the manufacturers of equipment, machine tools and such, and accessories. And AMT is the one that sponsored the development of MT Connect. That was my program. Yeah, that's a matter of how yourselves wish to work. Be more than happy to talk.
Okay.
They're certainly not competing standards.
No. Okay, got time for one more, John?
I was just going to say that there's no reason that you have to use PACML in packaging only. In fact, there is an initiative to look at other industries. So we really should get together and broaden the application. So anybody in this room who's not in packaging or not in machine tool, this means you should get involved in whatever industry you are in, and what pack tags, what differences in states or modes might make sense for you.
Okay, thank you. We have time for maybe one more question. Got one right over here.
Hi, Lee Smith, Metal at Toledo. I've recently been involved in an implementation of PACML on metal detection. One of the questions that I keep getting asked and I don't really have an answer for is about your kind of version numbering for PACML. So I seen a slide earlier this morning that talked about where you started in PACML version 2.2, PACML version 3. Then we've moved on to the ISA TR version, and you've got a new revision of that coming out. Do you plan on carrying on with the numbering of PACML? Are we going to see a 3.1? I mean, somebody says to me, "What version of PACML do you have?" What do I tell them?
The simple answer to that is right now it is an ISA part of S88. It is Technical Report 88.00.02. That's the official document. That will be upgraded, and Dan, correct me if I'm wrong, that's going to be upgraded to an RP. We don't know the exact number yet. But it will still be part of S88. That's the official document. To get that document, you have to go through ISA. They own it. We can't just put it on the OMAC website and let anybody come take it. So we're the ones driving the content for that document, but it's owned by ISA. Does that summarize it fairly well? Does that answer your question?
It summarizes it, but I don't know if you answered my question in that, if we're a machine builder, we want to advertise that we are PACML capable or compliant or however you want to call it. Do we just say that we are compliant to the ISA TR rather than we are PACML version 3 or something like that?
Version 3 is the same thing as no, you don't think? Is it not?
Well,
the new one will be
the
different.
new TR88.
The new one will be different. Okay.
So the only thing I would say is that versioning is dead. If somebody says they're compliant with version 3, then you say, well, that's old. You need to be compliant with the technical report. So it's basically what you said. So we really need to be compliant with the new ISA documents, and using that versioning language is old-fashioned.
As a matter of fact, we'll take that on as a note, and we will clarify that on the website. We'll make sure that that's well understood on the website. Okay. Well, thank you for your participation. I appreciate it. I appreciate all of the effort that's come from the member organizations as well as volunteers. We are making a huge difference in industry. I really believe that. I see the growth that we've had over the last years, and it's very encouraging. We would like to see that continue in 2014, and we would like your support to do so. And with that, I think we're done. The only thing that we will do now, for anyone who wants to stay in the room and see it, we'll put on the other video, which shows the packaging machine that we've shown at the Pack Expo, as well as Packology. Just a quick background. Actually, I'll tell you what it is in the video. So. Good morning, I'm Brian Griffin. I'm the head of electrical and automation engineering for Nestlé at our global headquarters in Switzerland. I'm also the chairman of the OMAC packaging work group, and I'm here at Pack Expo this morning for the unveiling of a new system that we are demonstrating here at Pack Expo that shows the value and the benefits of PackML in a real demonstration to show how it can be used for end users, machine builders, technology providers, and system integrators, and the benefits that they can receive from using PackML in their implementations. So what we have here, give a quick walkthrough of the machine, is we have 4 separate machines in this demonstration unit. The first one is a destacking unit, which is powered through a Schneider Electric PLC. It takes pucks and places them on a conveyor. The second machine that we have is powered by a Siemens PLC. It reads the RFID chip that's embedded into the puck. If it's a black puck, it turns that puck over so it's upside down. If it's a red or white puck, it lets the puck go through the system. The third machine on the back side here is a Rockwell-powered machine that takes that color information. If it's a white puck, it drills a hole in the center. If it's a red puck or a black puck, it lets it go through to the discharge unit. We then come to the front machine here, which is a Stöbli robot powered by B&R. It takes the pucks from the discharge unit and palletizes them by color, red, white, or black. And if it's a black puck, it turns it back over so that it's right side up. It then, when the pallet is full, it takes the puck and it places them back into the stacking unit, and the process restarts. So it's a continuous process. It's not high speed. It's not meant to be high speed. We're not showing packaging capability here. What we're showing is automation capability. So there's a few things that I want to describe to you that make this system unique compared to other systems that we typically see in the packaging world. First off, you will have noticed there were 4 different PLCs involved in this system. So 4 different automation platforms. And yet they're operating on one single communication network. So what we have is 4 different PLCs with 4 different technologies implemented in those PLCs, all using PackML. To get the system to work together, we needed to have a common communication platform. So we chose to use Ethernet, standard Ethernet, with the Weinsteffen protocol. Weinsteffen is a protocol coming out of the brewery industry in Germany. We chose that protocol because each of the 4 technology suppliers already had the drivers for that communication protocol on standard Ethernet. So what we have that I want to show that's different from what you would normally see in a packaging system is the fact that we can communicate on that protocol to each of these 4 different PLCs without the need for a line integration PLC. Now, one thing I want to state up front is we're not suggesting you don't have a line integration PLC. Any real packaging line, you're going to have a line integration PLC, and you're going to have to do integration. This is a demonstration to show that we can communicate with a standard across different automation platforms. So we don't have an integration PLC in this particular system. What we have then is, for example, speed information, which is set at the Schneider PLC. That's the start of the system. The Schneider sets the speed, and then it transmits that data to each of the other machines, and they follow the speed. Color information, for example, is only read at the Siemens Center, where we have the RFID reader. But the Rockwell and the B&R machines also have to know what color the puck is in order to do their operation. So that information is passed from the Siemens to each of those other machines using the Weinsteffen protocol, using pack tags within the PackML standard. We also send a lot of other information around the system, for example, what state each machine is in. If we have an error, The error shows up on each of the different HMIs. So the HMIs are associated with the controller. 4 HMIs from 4 different technology providers. But for example, if I have a problem with the Schneider system, the stacker gets jammed somehow, I can be standing at the Rockwell system and it will show me where the error in the system is and what the error is. So that from an operator standpoint, I don't have to run all the way over to another machine to figure out what's wrong with my line. I can get my error messages and my warnings anywhere from any of the HMIs, and it does that because they're all using the same tag-based information from machine to machine. So that's the first thing that we wanted to prove, was the fact that with the PAC-ML standard, we can communicate machine to machine regardless of what technology is being used. So part of the value of this system using PAC tags and PAC-ML is the ability to have an overall line integration SCADA system that shows what's happening on the line at any given time for any given machine on the line. So what we have here is an overview of the machine. We have the 4 modules, the stacking module, we have the RFID turning module, we have the ejection module, and we have the robot that picks and places onto the pallets. And what you can see is the state model, the state that each of these different machines happens to be in at any given time. So the operator can sit and he can watch this screen and he can see immediately if he has any issues on any of the machines in the line. Other information and value that he can get from this are things such as reporting. This particular report is a run from yesterday showing that everything was in a stop mode to start. Once we started the system, you can see red means stop, yellow means I'm waiting for something, and green means I'm running. You can see very quickly what the bottleneck machine is. It's the robot in this case. At a quick glance, the operator can see what kind of performance and efficiency he's getting. He can find out where his bottlenecks are. He can find out where the errors in the system are happening the most. Where do I have the most red bars? You can see here it's on the stacking unit. So it gives the operator a very quick view of what's going on in his line. Other things that we can do with the HMI would be things such as diagnostics, alarms and events. We can bring in specific data about each one of the different machines and where it's going, what's happening with it. We can do individual statistical reports on each machine, all from one central location using the PAC-ML state model, using the PAC tags, and following the PAC-ML standard. All right, we've gone through the operation of each of the different modules within the demonstration unit. But why did we do it? What's the value that we get? Well, by using PAC-ML and the PAC tags and all of that standard, we've shown that we can communicate from machine to machine without having to have a system integrator get down into the guts of the PLC code. They don't have to start looking for the permissive bit in this PLC to connect to the permissive bit in that PLC. They just use the PAC tags. The PAC tags help synchronize the machine, make it more of a connect and pack or a plug and pack sort of a system. That brings a lot of value to all of us in a few different ways. One way is the OEMs now aren't worried about having to give the system integrator all of their code information. They can protect their IP a little bit because a system integrator no longer needs to get into the guts of the PLC to understand how the PLC is working, why it's working that way, so they can integrate it. All they need are the PAC tags. It also allows us as an end user to be able to back up a little bit and not be so dogmatic about the hardware solution that we insist on using. Instead, we can say, use the hardware platform that best suits your purpose, machine builders. Give us a machine that does what it's supposed to do the best way that it can. But use a standard. Use PAC-ML so that we can take that machine that may be a completely different automation platform and make it work with the other machines around it. So it allows us to back off and get the better machines. It allows machine builders to focus on innovation. Focus on what makes their machine different from somebody else's, what makes their machine better, rather than trying to figure out how do I make my machine work on this automation platform that my end user wants that I don't know. So in the end, it benefits all of us. It also opens up the doors to the technology providers to sell their systems to more OEMs, to prove to the OEM why he should be using their automation platform rather than saying, well, my end user wants my platform, so you need to use that platform. And say, you need to use my platform because it's the best, and here's why. So we've shown now how PackML can be used to benefit all of us at a machine automation level. But that's down into the machine automation. How does it help the operator? Well, that's where Nestlé is taking this to the next level. One of the things that we have done is we've given a specification for what a standard HMI should look like for the operator. Now, this is not an automation task. This is being done in conjunction with our packaging engineers and our operators. What do they want to see in an HMI? How do they want to control their line? So we created this specification or template for HMIs, and we gave this template to each of the 4 different PLC suppliers that were building their machine. And we told them, use this template to create your HMI. They went away, they did all their programming, came back to us, and you can see, without any interaction with each other or with us, the HMIs look very similar by following this standard template. So we have the same sort of alarm bar at the bottom. We have a command bar for working through the menus. The commands all have the same names, the same positioning, so that you only have to train an operator once on the navigations of the system. After that, he can navigate through any of the different machines. Yes, he needs to learn how the machine works, but navigating to the different parts of the HMI is simple because it's consistent. He knows where to get to the recipes. It's the same place all the time. He knows where his diagnostics are. It's always in the same place. He knows how to change the speed of the line. It's always in the same place. So it brings a lot of value from an operational standpoint in being able to move operators from position to position, and they still understand how to operate the machines. In conjunction with that, we also standardized the light stacks. So we have a standard color coding that tells you, the operator, what is the status of my machine. So he can now stand back, he can look at the entire line, and when he sees a flashing red or yellow, he knows what that means. He knows that a machine is now in a different state. It's no longer executing. And he knows what that state is, and he can come to any HMI, and it will tell him what that alarm is. So if I have an alarm on the other side of the machine, this HMI that's a Rockwell HMI, even though that's a Schneider PLC, will pop up what the error in the system is. So from an operator standpoint in a real line, I don't have to go all the way down to the end of the line to see why the system is in fault. I can look at the HMI that's in front of me. And I can do that because I'm using pack tags. I'm using a PackML state model so that each machine understands what condition the other machines are in and what fault information there is. Through this demonstration, we've shown the value and the benefits that can be achieved and attained by system integrators, end users, machine builders, technology providers through implementation of an international standard, PackML. Progressive machine builders and system integrators around the globe are already implementing PackML systems. End users such as Pfizer, Nestlé, and Procter & Gamble are already specifying PackML as the standard for their new machines. Now is the time for you as well to have a voice, to be heard as we go and change the way that packaging automation is seen.